Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust and in Python, and we'll try to learn Rust in between. My name is Luciano, and today I'm joined by Roberto, who is
Hello.
this way.
Which way? Where are you? Okay.
And so if you never did Advent of Code is a code challenge that is published every year in the Christmas period. I know this is summer now, but we are still catching up with the exercises of last Christmas. Every Christmas season, there are 24 challenges. You can find the website on adventofcode.com. And we are publishing all our code for our solutions in Rust on a repository on GitHub. We should have a banner in a second. And we also have a link on the channel description here on Twitch. We also publish all the recording on YouTube. So wherever you're watching, you can find all the links in that channel. So last time we did the exercise year 2021. So last year, number 17. This time we are going to start exercise number 18. So I'm going to try to show you the README, and we are going to try to understand what that exercise is about. Okay, so I'm showing the wrong window, so give me a second.
I think you're showing the Python one.
Perfect. Now we should have the README. So this one is very big, so hopefully it's not going to be too boring. Hopefully we're going to be able to summarize it and go quickly. Okay, so keep in mind that every Advent of Code is a little story where we have to find or do something. In this particular year, we have to find a key in the ocean. So the team is traveling through the ocean and solving problems related to the ocean. This time we are dealing with a group of snailfish, and they basically want us to do their math homework for them. But snailfish numbers are not like regular numbers. Instead, every snailfish number is a pair, which is an ordered list of two elements. You can imagine left and right element. Each element of the pair can be either a regular number or another pair. So they can be kind of nested. So pair can be written as x, y, where x and y are the elements within the pair. And there are some examples here. For instance, 1 and 2 is a simple case, but they can be nested. So in this case, the left part is this one and the right part is this one, or the right part can be nested, or both can be nested, or you can even have multiple levels of nesting. So this particular homework is about addition. To add two snailfish numbers, form a pair from the left and right parameters of the addition operator. For example, 1, 2 plus this one becomes 1, 2 and this one. So it's basically you're adding square brackets around and replace the plus with a comma, right?
Yeah, 1, 2 go on the left, 3, 4, and 5 go on the right. And they don't go the other way around. So the position is important in a shellfish number, a snailfish number.
So there is only one problem. Snailfish numbers must always be reduced. And the process of adding two snailfish numbers can result in a snailfish numbers that need to be reduced again. So it's kind of a recursive process. To reduce a snailfish number, you must repeatedly do the first action in this list that applies to the snailfish number. So if any pair is nested inside 4 pairs, does it mean that there are like 4 open brackets, right?
5, because it's inside.
Okay. The leftmost of such pair explodes. We'll see what that means, I guess.
Yeah, because there can be multiple pairs at that level, but only the first pair that you find is the one that explodes at every iteration.
Okay, if any regular number is 10 or greater, the leftmost such regular number splits.
Again, there can be multiple numbers that are greater than 10 after you sum together, because in the input, you don't get numbers bigger than 9. You will get numbers bigger than 9 when you do the nested explosion. When you do the explosion at bullet point 1, it can create numbers that are bigger than 10. When you're done with all the explosions, you have to do the reductions and taking all the numbers that are greater than 10, but starting from the first one that you find from the left.
Perfect. Okay, because right now we don't see here any number bigger than 9, I guess. But yeah, probably we need to go through this. But...
You find the numbers bigger than 9 after an explosion.
Okay, once no action in the above list applies, the snailfish number is reduced. So again, this is something that probably can happen recursively multiple times until there is nothing to do. And at that point, you are done. During the reduction, at most one action applies, after which the process returns to the top of the list of actions. For instance, if split reduces a pair that meets the explode criteria, that pair explodes before other splits occur. Okay, so you don't go recursively multiple times.
You take your number, you check if there is something to explode. You explode the one on the left, the first one that you find on the left. Then at this point, you check it again for something to explode. You will not find that anymore because it's exploded. You can find another one, and then you have to explode that one. And you go on until you don't find anything that can be exploded. Once everything is exploded, you check for numbers that are greater than 10. And again, you take the first on the left and you explode it. If then you go in again and you check if there are explosions to do. If there are, you have to do explosion before. It's one step always before the other.
Okay, let's see how to explode a pair. So the pair left value is added to the first regular number to the left of the exploding pair, if any. And the pair's right value is added to the first regular number to the right of the exploding pair, if any. Exploding pairs will always consist of two regular numbers. Then the entire exploding pair is replaced with the regular number 0. So let's see an example here. So we need to get the ones that are nested 5 times, right? So I suppose this one.
I think you are missing some open brackets, square brackets in your README. I don't know if it's a problem of...
Let's go to adventofcode.com just to be sure. I think. Let's read it from here for once. Okay. Oh, yeah, actually, we get nice highlight. And I was missing a bunch of brackets.
Yeah, but probably you are... you have them in the code, but in the Markdown code. But Markdown with all that number of square brackets is probably giving up.
Or probably
let's read from
copy
here.
Paste, yeah.
Let's read from here.
Okay, so basically this one is nested 5 times because we have 4 square brackets, and then the fifth.
5.
Yeah, the fifth one marks the beginning of the pair. And 9 is the left one, 8 is the right one. So we are saying to explode the pair left value, so 9, is added to the first regular number to the left of the exploding pair, if any. So we don't have any regular number here.
So we don't do anything.
We don't do anything. And the pair right value is added to the first regular number to the right. So this one is added to the first regular number to the right, so 1.
Yeah.
Is it?
And it becomes a 9.
Okay, and it becomes a 9. Exploding pairs will always consist of 2 regular numbers. Then the entire exploding pair is replaced with the regular number 0.
That is the number that you find in becomes, on the right, together with the 9.
And why this 9 is removed?
That 9 goes summed on the left. There is nothing on the left, so it's lost.
Okay.
The 8 is summed with the 9, so it increments that 1 that becomes a 9.
So 8 plus 1, right?
Yeah. And the whole 9,8 in square brackets become a 0.
Oh, so the 8 jumps from here to here.
Yeah. Yeah,
and
then all of that becomes a 0.
Okay, so this one would have jumped on the left if there was anything, but because there is nothing, is lost. All of this is replaced by 0, and this one was increased. Okay, that makes sense now. Oh my God.
Second line is an example where there is nothing on the right. Same process, but there's nothing on the right.
So this one jumps and is lost. This one ends up in the 7, and all this one becomes 0. It ends up in the 4 and becomes 7.
And then everything becomes a 0. The third example is with something on the right and something on the left.
Note so this one becomes
the one
3.
On the right. Yeah.
Okay, go ahead.
Note that the one on the right is not at the same level or one level above the numbers that you have. It can be at any kind of level of deepness.
Okay.
Let's call binary tree.
Right. And then we have this one, which is, in this case, this one doesn't have anything on the right, right?
No, it has a 6 on the right.
So it can also jump.
Yeah.
Cool. So this one will
It's not a matter of...
Okay. That makes sense. And this becomes 0.
Yeah. And this is how you explode. Then there is the split operation.
Okay. To split a regular number, replace it with a pair. The left element of the pair should be the regular number divided by 2 and rounded down, while the right element of the pair should be the regular number divided by 2 and rounded up. For instance, 10 becomes 5 and 5. 11 becomes 5 and 6. Okay, that makes sense. So rounded down, rounded up. 12 becomes 6 and 6, and so on. Okay. There is the process of finding the reduced result of this one. So after the addition.
The addition is putting one
just
on the right.
Square bracket, and a comma here. Okay.
And a comma. And it's that one.
Then
you look inside.
And you need to find for something that is nested 5 times, and you start with that one, right?
I think you start with 4 and 3 up there.
Oh, okay. So
yeah.
5. Right. Okay. So this is 5 times. So we need to explode this one. So this one is lost. This one goes here and becomes 7. So 0 and 7.
Yeah.
Then we continue. And which one is the next one to be nested? 5 times probably is this one, right?
Yeah, that is the highlighted one.
So this one goes here, and this one goes here, and this becomes 0. So 15, 0, 13.
Yeah.
Right?
Yeah.
And then we keep going this way.
Now we split. Let's look at the split, because the split is important. We split the 15, that is more than
here we split.
9.
Yeah, you're right.
Yeah.
So this one needs to split into rounded down. So it will be 7 plus 8. So it becomes this.
Then you do 13, another step. That
and
becomes 6 and 7.
Okay.
But then something will be nested more than 5 levels. So you have to explode again. Who is that is nested more than 7? Probably that 6 and 7 there that you are highlighting.
One.
Yeah.
So this will go 6 here, and this 7 will go into the 1. So 6, this becomes 0, and this was 8. Okay.
At this point, we can't do anything else because there is nothing indented more than 4 times, and there is no number above 9. So the number is reduced.
Okay, so your homework assignment involves adding up a list of Snellfish numbers, and we can check the input there. So this is how the input looks like. It's just a list of expressions. It doesn't have the addition, right?
No, because you have to add every line with the one below.
Oh,
the plus is a GitHub.
Cool. The Snellfish numbers are each listed on a separate line. Add the first Snellfish number and the second, then add that result and the third. Okay, so you keep merging them.
Yeah, you have you start with an accumulator with the first line, you add the second line, and you put back in the accumulator, and you go on for all the input like this. At the end, you will come out of all this input with a number, a Snellfish number, not a real number.
Okay, now I remember why I didn't do this exercise last Christmas. Probably I stopped just reading alpha this readme. And
I have to say it was very tricky to get how the number were exploding and splitting. It was a little bit tricky to understand.
Okay, so basically what do? You keep going like that, and you sum all the numbers in the list. Okay, until all the numbers in the list have been used once. For example, the final sum of this list is this one. And what do you do?
Yeah, go on. Now he's explaining you how to do the sums. You have more fun when you're done with this. Scroll.
Oh, this is the list that creates
that is the list that is giving that. There is nothing indented more than indented. There is nothing more than 5 level dips. So there is no explosion, no splitting, nothing.
Okay.
The next example is more interesting, because when you add 5, 5, at that point, the first one will be 5 level dip, and you have to apply an explosion to it.
Okay. So these are just test cases that we can use.
Yeah, those are test cases that you can implement in your test if you want to try your sum function.
Okay.
Then the README provides this slightly larger example.
With this other result. Oh, this is the full operation.
Here is explaining everything, but you will have an headache if you try to read. This is ugly.
Yeah. Okay, to check whether it's the right answer, the Snellfish teacher only checks the magnitude of the final sum. The magnitude of a pair is 3 times the magnitude of its left element plus 2 times the magnitude of its right element. The magnitude of a regular number is just that number. Okay, for example, the magnitude of 9 and 1 is 3 times 9 and 2 times 1. Yeah, 3 multiplied 9 plus 2 multiplied 1, 29. The magnitude of 1, 9 is 3 multiplied 18. No, 3 plus 18, right? 21.
Yeah.
Magnitude calculation are recursive. The magnitude of all of this, okay, you do this one first, then you do this one after, and then you do this by 3.
Yeah, then it's 29 by 3 and 21 by 2.
Okay. We have a few more examples. So at the end of the day, you just get one number. And blah, blah, blah. Okay. Add up all of the Snellfish numbers from the homework assignment in order that they appear. What's the magnitude of the final sum? Okay, cool. Did we get it? I think we lost everyone in the stream.
Yeah, there are people saying, okay, I will go in a farm and raise pigs.
Cool. Do we want to see the Python solution?
Yeah.
Okay, let me switch screens.
Just to be clear, this was not the first solution that I did. The first solution that I did was way uglier than this one, but really horrible to read, horrible to explain, more complicated, slower, everything. Now, how is this solution working? I don't want to say that this is optimized. It's not. It's just better than the first version. Here there is an example of a snailfish number. You can think of it as a free. There is something on the left, something on the right, so it's binary free. On the left, there can be another free or a number, and the same on the right. So this becomes a free like this. This instead becomes a free like that. Trying to approach this with frees was my first idea. I tried it. I failed because when there is to sum the number to the one on the left or to sum the number to the one on the right, because you have to jump between levels and look for the numbers, the code there was a little bit complicated, I like to say. So I just fall back to a list, a vector of numbers. What I implemented my integer class. This integer class is containing a real integer, a number, and a left-right position. So this LR is a string in Python that tells me where the number is in the tree. And I will show you later what it's inside.
So it's like an idea of coordinates of that node in the tree.
Yeah,
right?
coordinates of that number in the tree. Then I implemented a parse function. The parse function is giving back a list of numbers and the position of the numbers. So a list of this int class. Is splitting the input string in open square brackets, closed square brackets, a comma, or a number. Those are the 4 tokens that we can find in every input string. This is my current position in the left-right coordinate system. For every token, if it is an open square bracket, it means that I'm moving on the left. If it is a closed square bracket, it means that I'm moving one level above. If it's a comma, it means that I'm going to the right. And if it's nothing of all of this, it means that it's a number, and I put the number token into my sequence return value, that is a vector, in Rust will be a vector, with position LR, that will be, in Python is a string, in Rust we think what is better. It's basically a sequence of left or right decisions, so I don't know what is the best. Could even be a number if we use bitmask, but I know that Luciano with bitmasks, you are not, you don't like them.
Nope. I'll probably
Then
go with a vector of enums. But
yeah. Then there is the reduce that is doing that job of looking if there is an explosion or looking if there is a split. So here I'm looking for an explosion. There is an explosion when my coordinates are five coordinates. If I'm left, it means that I'm 5 level deep. At that point, I have to explode myself. To explode myself, if I have something on the left, I sum myself to the element on the left. If I have something on the right of my right element, so it's +2 and not +1. I sum the element on my right, the +1, to the element on his right, if there is something. And I replace myself with an integer with 0 inside that will have a position of, if I'm left 5 times, it will be left only 4 times, because we are getting up 1 level. And I remove from the vector the number to my right that is we have to get rid of it from this list of numbers. If there is something to remove from the list, I remove it from the list, and I return telling that I did something, because we have to do something until there is nothing to do. So I return the sequence. So in this way, I just touch the leftmost element, like the README was saying, and I give out to who's calling me that probably there is it can be still work to do. If I don't find anything to explode.
Why didn't you use a dictionary where the keys will be this coordinate system and the value?
To keep track of the leftmost.
Okay.
Because and also to keep track of what's on my right, because you saw in one example that the one on the right was not the one above then down, it was going through the tree. So keeping a list is super fast to go left and right,
because the list is always somewhat ordinate.
It's not sorted, but is in the order that you see in the input. And so going left and going right is just +1 -1. Instead, if you go with a dictionary, you still have the tree represented in the right way, but at that point, moving the element to the left and moving to the element on the right is expensive, because you have to walk instead of doing +1 -1. That is just a sum. Then it's true that inserting and deleting from a list can be an expensive operation, but like I say, this is not an optimal, beautiful solution.
But I suppose if you use a linked list.
Yeah, if you use a linked list, it's less expensive. You can use a double linked list. That depends on the internals, but cool. Then you have to see if there is something to split. Explosion is done. Then look if there is something to split. You look if there is something to split, looking if there is something greater than 9. If it's greater than 9, okay, I have to split. I break because I just split the leftmost one. If there is something to split, my number is this one, my position is this one. The one on the left is the one divided by 2 rounded down. This is an integer division, so it will always round down. The number of the right is the original number minus the previous one, because you round, they must sum together to the same number. I put in my position, the position of, for example, now there is a 15. In this 15, I put a 7, that is with position what I had but left, because I will put a tuple, one will be left, and the other one will be right. And I put it at my position plus 1. So I insert in the vector at my position plus 1. I modify the one at my position, where there was the 15, but I tell that it is one level deeper. And I add another one in the vector, telling it is on my right and is one level deeper. And I again give back the sequence, telling I did something. If I'm not triggering any of those 2 conditions, I return the sequence, but I say false. I'm done. There is nothing else to do on this number, on this shellfish, how is called? Snailfish, sorry, not shellfish. Snailfish numbers. Then there is the sum. The sum, what is doing? Is taking the input. I set up an accumulator to nothing. For every line in my input, if the accumulator is nothing, I parse the line and I go on. Now, I create a new snailfish number with all the numbers in the accumulator that will go on the left, so this left, and all the numbers in the parsed lines that will go on the right. So
okay,
they go right and they go left. Then I have work to do. While I have work to do, this new variable is the reduced version of itself, and I also take out the work. When I will land in this line, then there is nothing to do. This work will become false. This while will end. The accumulator is now the value that I have. When I'm done with all the inputs, I will return the accumulator.
It's interesting, that line where you do new comma work equal reduce. I would have expected that you create a new variable shadowing the previous work. Instead, it actually reassigns that work in Python.
Yeah.
Right? Okay. I think if that was JavaScript, you will do something like const equal all of that, and it would be like a new variable.
No, yeah, I'm going above it.
Okay, so with like you are destructuring but also reassigning at the same time.
Yeah. Then there is the magnitude again from the README. Here I will show you something like this. I will have a number and this position in the 3. The position of this one is left, 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 left. Then there is a 7. Its position is left, 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 right. Then I have another 7 with this position, and so on. To compute the magnitude of this number means that the first time it is on the left, so it is by 3. Then his node is on the left of something else, so it's by 3 again. Then all of this is on the left of the node, so it's by 3 again, by 3. So every time there is an L, I do by 3, and every time there is an R, I do by 2. So I take all the numbers in my sequence, I compute a multiplier. The multiplier is by 3 if there is an L in my position, and a 2 if there is an R, because it's the only possible other value, so I'm doing else instead of else if. At this point, I have the multiplier to multiply the value and to add it to the final magnitude of all this snailfish number. I do the final sum and I return it. Oh my God, we are at the end of all of this stuff and we have our magnitude. Here I made, those are the README tests. If I run them, you can see that it's not fading, so it's running. So like in the README, the magnitude of parsing the string is 143, and so on. What is inside my accumulator, inside my, what is that the parse is giving back? Parse is giving back this, a list of, in my case, integers that are my fake int class that contains a number, like I said, a string that is representing the position inside the tree of the number itself. So there is no nested structure here. This is a linear structure. So it's easy to handle, it's easy to go right, it's easy to go left. and I still preserve the position in the free that is needed for the magnitude. In the end, this magnitude is the one from the example in the README for 140, and then there is the magnitude of my input that I think is different from the Luciano ones. We can try to take it, and if you run it, it's quite fast, so it's not. And this is my input. We can take Luciano once if we want live to see if we are able to crash everything. Let me take his input.
Meanwhile, thank you for the follow, Jesse. How are you doing?
Let me second that I have to copy the input. It's not that easy. Okay, run. Is 4235 your number? Like a magic trick. Is this your card?
It is, yes.
It's your card. The two of clubs. I don't know. The spades. Two of spades. So this is part one. Do we want to do this in Rust, or do we want to show part two before that?
Yeah, let's try to do this in Rust first, because I think it's already complicated enough, and hopefully we can
But,
do it
to be honest, part two is easier because you are using everything that you already wrote just in another way. But yeah, we need the concept of parsing, summing, reducing, summing, and computing the magnitude. Those are the four concepts that we have to implement in Rust. And also the concept of number with disposition. Now I don't know what you want to use, but let's try to mindstorm around it.
Okay, so let me switch the screen, and then we'll figure out how to do this in one way or another. So let's see. You should see the README, and I should be able to switch to Visual Studio Code, where we already have started a scaffolded solution. So it's like the Volkswagen test. It just returns what we want to return, but now we will try to implement it for you. So where do we start? Probably we should define a struct for, what do we call it? SNum, snail fish number, I guess. Value, and value is a U32. It's never negative as far as I know.
No,
right?
it's never negative. And also they are always very small numbers, but they can sum up to bigger ones. Let's keep U32. Otherwise we land in casting U8 to U16 and
Okay.
I mean, in the Python solution, those are character left and right, but basically it's a binary concept, left or right. If you want to do an enum, it's fine. If you want to use you're using an enum.
Yeah, I want to use an enum.
Okay. I know that you like your enums.
Exactly.
So now that is a vector of positions. Yeah.
Cool.
Why is complaining about that?
I think because we're not using it yet.
Oh, okay.
Cool. Okay, so the first thing that we should do is maybe the parse function.
Yeah, let's start from the parse and write some tests about the parse.
Okay, so if we write parse,
is it from string? Do you want to implement a from string for this? Okay.
Oh my God. Should I disable Copilot?
The snail number is a sequence of snum.
Yeah, exactly. So the input is a string. So let's say line is it's an str, and the return will be a vector of snum.
Snum.
Yeah. Okay, cool.
Can we call it smooth? No. Okay.
Okay. By the way, we have a special guest today, which is GitHub Copilot. Let's see how useful that is. Look at this. Is it? I don't know what the hell is it thinking, but
what is doing?
I don't want to know. Let's not get too much distracted.
Value by 10 plus z. Copilot, mind your own stuff, please.
Okay, cool. So how do we do the parsing? Because you use a regex.
I split the character with a regex, yes. To be honest, in the input, there is never a number with two figures. Take a look at the input.
Okay. Yeah, I think you're right. I had a look before.
So you can just go in by character. You go through the string character by character. So we can have square bracket, open, closed, comma, or a number. We can have those. Yeah, we never
have no D2, basically. So yeah, you're right.
No. So we can parse character by character without problems.
Okay, and we do a mega match with either all the numbers from 0 to 9.
But you can do a default. You check square open, square closed, comma, and in default you assume that is a number and you try to parse it. Worst case, it
Do we
explodes.
want to do an enum for all the possible tokens? They're gonna help.
What do you mean by that?
Something like that. Enum token, and this can be either open, close, comma, num, which is going to be U32. That's it.
Okay.
And then,
well, in the comma is not with 2M.
Right, that's another thing. That's a comma. We don't want to be in a comma. Okay, so let's do a tokenizer. Tokenizer takes a line and an str, and it gives us a vec of token.
There are no
Right.
generators in Rust, you said yet. Okay.
So, okay, no, not all of it. So let mute tokens equal vec new. Yeah, I like up to here. Then mind your own business. Copilot. Okay.
Yeah, for seeing line chars is
for
fine.
char in line. And what we do is like match of...
It's not a line chars. Line.chars or something like that.
I think that works anyway. Let's see. So what we want to do is match char and this. And basically we have this case. And this returns...
open. Oh, nice.
oh, you know what? Can we use... Okay, we can do this. We can do line.chars.map and do that, right?
You take the functional approach. Yeah.
So then we can just use collect at the end.
I like what he's writing, except that he's using the round ones and not the square ones, but I think he's correct.
Okay, let's go with that. And then we'll adapt it. Thank you, Copilot. Very close.
Very close. Yeah, not there. Open, close, comma, number D, 2-digit, radix 10. Yes, unwrap.
Okay.
Impressive.
To be honest, here we could do something a little bit more...
dot 9? No. Can you do dot with strings?
No, because those needs to be number. Actually, if you do the Unicode characters, probably yes.
If you do dot try to do dot
those will be different.
9 equal.
That might work.
Put the equal after the dot. No, he's complaining. Okay, good.
Why not? Let's see. Oh, experimental.
Exclusive range pattern is experimental. Okay, nothing. Okay, go to what you were.
No, let's leave it as it is before, but in theory, let's add a to-do. Handle possible errors, which we never do. Let's assume now it's good.
But like in production, come on.
So we can return this
get a 500 and you leave with it.
Actually, you know what? We can just return an implement iterator of item token, and we don't need to use collect.
Now is
why not? Wait. Hidden type. There is a way to do this. I think we have done it before.
I have no memory.
Yeah, I am relying on Tommaso to help us. Come on, Tommaso, help us.
Iterator, you have to return an iterator type.
Does it need to specify some light? Hidden type for implement type captures lifetime that does not appear in bounds. Okay, do we need to say a str? And this needs to be plus a. Now?
One day I will
lines is a reference. Lines is a reference. And then?
You can't charge it? Oh, you can.
So the return type must have a plus a, which is what we are doing, right?
Now it's complaining about?
Or is the item that needs to be a token plus a? No.
The tokenizer.
Tokenizer a.
It must be declared in the function name with the square brackets.
Oh, yeah.
Brackets.
You're right.
No,
yeah,
I'm not
good
right.
One.
Is W Gaffa that is right. I just
thank you, W Gaffa. That's really good. Okay, perfect.
Okay.
So we are not
our
handling
tokenizer.
errors. So this is a tokenizer, and we can use it as an iterator. So basically, what we can do now is we can iterate over the line.
Yeah.
So we can do tokenizer of line of str. No, sorry, line.
Line.
And this basically is an iterator. So now we can do map, and we will have tokens, right?
We have to declare before looping our current position, that our current position is empty. We are not. We are outside of everything, because we will have to update it while we go through the map. So we have to
then let's not do a functional approach. Let's do let move position equal to back of nothing, and this is back.
Is a vector of pos. Yeah, exactly.
Oh, we can do default, I guess.
Default. No.
How is it? Is it like this? I don't remember anymore.
I don't know if pos has a default, so.
Oh yeah.
Go with an empty. Yeah.
Okay, then we need to do for token in tokenizer of line. Now we have a token. Cool. Look at this. How good is this? There are random things there.
I have to say that is not perfectly correct. I mean, because when there is a clause, we have to remove from position, not push stuff, and we have to add the R when there is the comma. But yeah, if you switch comma with clause, probably we are almost there. Okay, then I don't know what is all that stuff there.
Let's copy this and let's see what happens.
I don't know what is there.
So when it's open, what do? We push an L. This is correct.
Yeah. When there is a
close,
comma,
we remove.
When there is a comma, we add an R.
Okay, so let's.
But we also have to remove the last element that is an L. So
what do? We do
A is a pop of the last element. We have to discard the last element, and then we have to add an R. That is what is suggesting. Cool.
Then when it's a
close, we have to pop the last element, because we are going up one level above, and we have to discard it. We just want to remove it from the position. Okay. And when we find a number, we want to push in our return object that we didn't create.
Right. Let
mute
stack. Is it a stack? No. Let's say expression. Expression is a vec of snum, and let's do vec new.
Yeah. In num, we have to expr push. As num made, it's also the clone is right. Fuck, I was about to point out that here we have to clone. Here we have to clone because position is changing, and we have to or probably we have to implement some.
Yeah, we need to do a bunch of stuff. This one needs to default derive. Sorry, I haven't done Rust in a while. I feel default. Let's put debug as well, just in case we want to print something.
And also
this
pause
one
must. Yeah, this
and
must also be clonable.
Clone, yeah, and clone here as well.
But I don't think we have to clone that. But well, let's leave clone there. I don't think it will be needed. But
that default doesn't work. Oh, it's experiment.
Default for enum is experimental. I don't derive default.
Okay.
And also for the token. I don't think we need the clone on the token, but
now position pop. It doesn't like it because it's returning something. No, why doesn't like it?
There is remove instead of pop. How do you remove the last element of a vector, discarding the value? We don't want it.
I think the problem is that we want to do this. Okay, cool. Yeah, I was considering as expression being returned. But we don't
because
want
in line 36, probably there's a return of some kind of value.
Yeah, because I think the return type of every arm needs to be consistent, and we are not returning anything anywhere.
Okay.
Cool.
Let's try to write a test for this. At this point, we have enough code to write a parse test.
Sounds good. So let's write a test for, let's say, fn test parse.
Parse is something simple.
We have. Do we have the examples from the README? Do we want to?
I like what was writing your friend.
1, 2, 3.
Yeah, changing 1, 2, 3 to something else, but is a good start. Even the expect. My God.
Okay. Can we go on and let Copilot to do the stream?
This is not a valid input. You have to put another bunch of and another open. Okay. So one will be left.
So the first one will be post left,
post left. The 2 will be left right. That is already correct.
We do use post asterisk, and then at this point we can do L. L.
The 2 is left, then right, and the 3 is just right. Just right. Because it's a level 1 object and is on the right.
What? Right. Okay.
Let's try to run.
I think we need to implement the equal thingy.
Okay.
EQ. Is that it?
No.
Maybe it's num as well. Needs to be EQ or not?
There was a partial EQ in the suggestions.
I don't think we need that. Okay, let's see if this works.
No.
Didn't work. Partial EQ is required by EQ. Yeah, thank you. And now we probably need to, still probably not valid because we are also comparing the snum. So snum also needs to have EQ and partial EQ. See? Okay, now it's happier.
Now we have all the EQ that we need.
Works.
Yay!
And if we do just or just to see if it fails.
I hope.
It did fail. Let's see how the message looks like. Okay, left is LL, L or, while we are thinking it needs to be LL, L or. Cool.
Okay. If you want to take from a README a more complicated example, we can try also that one. A longer string. You can copy and paste this example if Copilot is not doing that for you.
So from the example in the input or the README?
I'll take the README. There are plenty of strange animals.
What do you want to get? This one?
Yeah, not something that is too long because otherwise we get mad. Take that one. I mean, complicated enough.
Thomas is giving us good suggestion.
Only partial EQ is needed.
Let's see. Because we are not doing sorting. Is that the reason why? We are only just comparing if they are the same or not. Yeah, that's definitely true. Still working. Thank you, Tommaso. That's a very good suggestion. So let's do another one. By the way, this might be an interesting case where if we only learned how to do macros, we could have generated a macro to do LL like as a one word.
Okay. And everything. Okay, cool. No, I don't know how to write macros. Sorry.
So let input equal this. And now, okay, now we're going to have fun. Let expected equal vec of.
I see some degeneration. I see some degeneration in Twitch. Okay, fine.
I'm going to do constructor because we can make our life easier. Thank you. I think I really like the first one, but not anything else. So I'm going to remove all of that.
Getter and setter. Why you don't want the getter and setter?
I don't want them.
Be a little bit more Java.
Okay, so now what we can do is new. If I can type.
Not a colon.
Oh yeah, you're right. Sorry, JavaScript. I've been doing JavaScript for.
I was doing Python on the weekend. Today, working with Java. I was trying to throw exceptions without the new in front of it. Why it's not working? Why it's not working? Okay, I forgot the new.
Okay, so this should be a little bit more readable. And thank you, Copilot, for auto-completing. Why it doesn't like
it? Now is
one argument found two because Copilot wasn't too smart there.
Yeah.
Position.
And also not vec new, but you have to
vec of pos.
Pos.
And this is position. Okay, cool. So we have that.
Almost smart enough. Almost.
Okay, so now we have one is just vec of L. it's
You
L,
don't,
L,
you don't have
L,
to use you don't have to use a snum new. Sorry.
You're right. Sorry, I'm tired today.
No, it's vec. You have to keep vec, but inside all the elements are snum new.
Cool. So
Okay.
the first one
is left, 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 left. For left. Yeah, exactly. Good guy. Good guy. 2 is left, 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 right. Autopilot
almost
is not right. Almost left and right.
Then
3 is left, left, right, left. Okay. Is right. 4 is correct. He's learning. Oh my god, he's learning.
Left, left, right, right. Yes, okay.
Oh my god, he's learning.
5 is complicated. Let's see.
Left, right, left, left is correct.
Oh god. Then 6 is the same,
Correct.
but the last one is right. Yeah. Now we have left,
right, right, left. Correct again. Left, right, 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 right. Correct. Let's see if it gets 9. I'm worried.
Oh my
Fuck,
god.
got it.
maybe he's executing the code.
I'm going to learn woodwork. I need a new job, guys. I'm getting unemployed in 3 weeks.
Okay, so what doesn't like it here? S now. Oh,
with capital N. With capital
it even learned my own mistake. Look at that.
Yeah, you see, we still have a job. We can still have a job.
Okay, cool. So this one worked. Perfect. So what do we do next?
Test are green. Sorry, you were too fast. I missed the run.
Everything is green.
Okay.
So let me rerun.
Okay, let's try to implement at this point the sum of 2 snailfish numbers. Now we have parsed them, or we implement the magnitude, one of the two. There are examples of magnitude in the README. We can start from the magnitude if you want.
Okay, let's do that.
Okay, start from the magnitude, like we call it. That is taking a snailfish number, so a vector of snum.
Yes, I'm trying to see what Copilot is saying. By the way, either 6969, thank you for the follow. What are you doing today? Okay, so here we get a vector of snum, so that's fine. And we want to return a U32. That's good. Then what do? We need an accumulator.
We fold. Can we fold?
We can fold, yes. We can do exp.ether.fold. Yeah. And the init value is 0, right?
Yeah, and the function is?
And the function is something like that, where we need to do something else, probably.
Very similar, because we have to do Sn is the vector. No, what is Sn? The
current value.
snum.
What did I do?
I don't know. You jumped in the hyperspace.
So accumulator is the total value so far, and snum is the current value that we are folding.
Now we need to convert our vector of pos into a number and multiply that number by the value of Sn. Sn has value and position. We have to multiply Sn.value by some function that is computing from Sn.position.
Okay, yeah, right.
We can, again, Sn position can be a fold. Try to write Sn.position.iter.fold. Now, can we fold on top of a vector? Do we have to go to an iter?
We can fold. So first of all, let me reply here. Either, thank you for following. So we are doing Advent of Code in Rust. So we are also learning Rust. So you are welcome to learn with us. And we are doing an exercise from last year, number 18, where there is a bunch of Advent of Code. There is a bunch of expressions like this, and we'll need to kind of manipulate the stuff and do operations over this kind of lists. So it's a bit messy, but bear with us, because probably we'll explore some interesting Rust things, and you can help us.
Or we'll explode.
Okay, so Shubham, hello, welcome as well. Yeah, I'm going to repeat what I just said. We're doing Advent of Code, exercise 18 from last year in Rust and learning Rust in between. Cool. So we want to do snum, so sn dot position dot either.
A fold. You have to do iter before fold. My God, I'm worried. It's almost right.
By the way, for people that just joined, we are using Copilot, and we are being impressed that sometimes it's being very useful.
And I'm scared. The accumulator starts at 1.
Accumulator starts at
1.
Wait, where is it? The accumulator here. 1. Why did it put ACC? 1. Okay, and this one goes
multiplied by 3.
Multiplied by 3, and this one is multiplied by 2, right?
Exactly, because right is by 2 and left is by 3.
Okay, so once we have this, what do we do?
Is ACC shadowing the one above and getting any problem? I hope not.
ACC.
They are both called ACC. It's not a problem.
No.
Okay.
But if we need to reference the other ACC.
No. We before this or after this, we have to do multiplied by SN dot multiplied by
So
SN.
this value needs to be multiplied by
what Copilot is saying, plus the accumulator.
Plus accumulator. Okay, perfect.
So let's write a test for the magnitude. We have 6 examples in the.
Okay, so we can do a test, and we do fn test magnitude. Oh my god, what are you doing?
Do you want this is very similar to the Python test that I wrote. Do you want them somewhere in some chat? Do you want me to copy and paste it to you, or we are writing it?
They are in the README, right? We can copy from the README.
Okay.
So they are at the end, right?
Yeah, almost at the end.
This one, right?
Yeah, copy those guys.
Okay, let's copy all of this, and we'll do a little bit of string fun. So
basically, we can assert equal that magnitude of parse of that string is 143.
Okay, so
I don't think you have to let anything. We can do everything in one line.
I was just creating a vec of cases.
Oh, you are so posh.
And every case is literally a string.
A tuple of string integers. Okay.
Exactly, yeah, that. Pretty much that.
You are creating a fixture map.
Pretty much.
Yeah, I remember fixture map and all the problems that they generated. There was a guy I was working with that was really an enthusiast of them. Was using them even when there were 2 values.
Oh my god! Okay, no, that's
even for one. Once he did all the loops with multidimensional loops for only one test case, and it was like, it's just one test case. Oh yes, but if in the future they will become more, you will write the loop when there is more than one.
Premature optimization.
Yeah. The guy was a genius of premature optimization, and he used less complexity also.
Okay, I think I messed up something. Look at that. So the first one is 1 for 3.
Yes.
1 for 5 got lost.
Yeah, you are off by 1. Yeah, something new. No, developers are never off by 1, right?
Never. I'm never off by 1.
Never. It never happens.
Okay. This one completes our beautiful cases.
He's complaining about something.
Because we are not using this. Okay, now what we want to do is
we don't need a pause here. We don't need pause.
Oh yeah, we don't need pause. You're right. We need for input and result expected, right?
In cases.
What we want to do is expression parse input, magnitude expression expected. Perfect. Thank you, GitHub.
Can't you put the parse inside in line 142 instead of creating a variable?
You definitely can.
You see, Copilot is not always telling you.
It was more readable. Come on. Oh, you might have
because it's a reference.
You might have an issue with doesn't live too long.
Okay, go back to what Copilot was saying.
But you can just borrow. Is that enough? Yeah, that's enough. Okay, cool.
And if you run this?
If we run this, let's see what happens. Works perfectly. Now I'm gonna break something just to make sure.
Yeah, to be sure. Let's have a red.
Yeah. Okay, there was a red. Cool. I think we can also do here. Can we add a message?
Please fix it before you forget.
I just want to add input. It not match input. Just to see. Oh, sorry. Just to see that if we run this test, the message should make sense. Should tell us which one failed. Yeah, did not match this one. Okay. 4. And this was the one we changed. So if we run it again, now it should be green. Copilot, calm down. What are you doing?
Yeah, those are not valid inputs. You are inferring too much.
Okay, perfect. So this was green. So what do we do next? We need to do the explosion and the sum.
We have to do the function that is doing the reduce. Yeah, that is doing the transformation. That can be an explosion or a split. So this function that we have to write must check if there is an explosion to do. If there is an explosion, must do the explosion and return the sequence. If there is no explosion to do, it has to check if there is a split, do the split. If there is nothing to do, it has to return.
Okay, so we need to do, what do we call this? Calculator?
I call it reduce in mine, but because
I like reduce.
I don't know, is a reserved word in Python?
No, in Rust, I don't think so.
Sorry, not in Python, sorry.
So the input is going to be an str, or...
No, the input is going to be a vector of snum.
Yeah, do we consider that we already cleaned it up? Okay, cool. Or it can be an iterator of snum.
Depends if you wanted to alterate the vector or create a new one.
I will say create a new one.
At every iteration, okay. And then we have to return a vector of snum or again an iterator of snums.
No, I will return an item, like directly the result, a vector of snum. Yeah. Right?
Yeah, and we have also to keep track, if you want to use the same paradigm, if there was some work done on top of this vector or if there was nothing done.
Okay, so we can return a bool.
If you want to keep the same... Because otherwise what you have to do, you have to check if what you gave as a vector is the same that you got back. At that point you stop, but it's a little bit expensive when you can just return a boolean and say if there was some job done or not.
Right, then let's not use now I understand what you meant. Let's not use an iterator. Let's use a vec of snum.
It's an optimization we can do later if you want.
Yeah, exactly. Let's keep it simple for now. So
this one, in theory, we could even modify in place the vector and returning only a boolean. I don't like it a lot, to be honest.
Do we want to do the sum first? Because this one looks a little bit more advanced.
But the sum must call this.
Does it? Oh, yeah, because after you sum, you always need to
reduce. You take two stuff, you put them together, you go on until you reduce, then you take another one, you put together, you reduce. So sum need the reduce.
By the way, Tommaso is suggesting something really cool. We can return. Can we return an option? Because we
always need the vector, even if we did nothing with the vector.
Another option could be, but maybe we will have pain with lifetime. If we do a mutable reference,
we can modify input in place.
And we just return a boolean.
Okay, we can also do this. Let's start like this, make it work, and then we can optimize.
How do you do it?
Where do you have to put the mute?
I was wondering the same. I think it's like this, I would say. Is it? Okay, thank you. And boolean, of course, we're not returning it yet. Cool. Okay, so
why magnitude on line 62 is still underlined?
Because we are using it only in the tests, not in any public code.
Okay, sorry, it's not counting as used if you use that in the test only. Okay. So now here we have to look if there is any. We have to look in the vector for the first element that has a position of length 5, if there is any.
Okay, so we need to do.
We can
use, I think, a find. Yes, so we can do let item equal input.
Well, we need a position more than the item itself, but okay.
Yeah, find will give us the position. I think it's actually called position. And the predicate will be sn, where sn.position.len is equal to 5.
3 equals because
I'm JavaScript. And this one is an option because it might not exist, right?
Yeah. And this is not an item. This is a position at this point.
Item.
An index, position.
Let's say index. Okay.
Yeah. This will be the index of a number in a tuple of number on the left, because it's the first that we find, right? If there are multiple numbers, it gives you the first one, right? Position.
I think so. Let's check the documentation. Searches for an element in an iterator, returning its index, position takes a closure, it applies its closure for each element of the iterator, and if one of them returns true, then position returns some index. If all of them return false, it returns none.
Is a short-circuiting. If you were scrolling, it was saying position is short-circuiting. In other words, it will stop position as soon as it finds the true. Okay, it's giving you the first one.
Cool. So what do we do if it doesn't have this?
We have to check if there is something to split.
Okay.
If it doesn't find it. If it finds it, we have to sum to the left, sum to the right, and
index to explode.
Yeah, index to explode. Explode index to explode. Perfect.
Okay, so if there is something to explode.
Yeah, let's keep this, then we change it.
Cool. I have no
Also,
idea.
in line 81, return false.
81 return false, yes.
Yeah. Okay, if there is some index, we don't have to remove it yet. What the fuck is doing it?
What was the logic? Let's not.
The logic is not read this. The logic is I have to sum the value of the found with one on the left if there is anything. So my input index.
So we need to figure out if there is something on the left and something on the right, and then
if my index is greater than 0 means that there is something on the left. So if my index is greater than 0, because if is 0, it means that is the first one and it goes lost. Like okay. Okay, if there is something on the left, the one on the left must be incremented by my current value. So
okay, so we need to get let mute on the left.
Num. Yeah, on the left it will be a num.
It will be an input of get index -1, and we know that there is something because
we checked.
Yeah, and now we want to do this
on the left dot value
plus equal snum value.
On the left dot value, okay, because we have to increment only the value. We don't have to do anything else. This one dot value.
Do we need to use get mut maybe? Yeah, I think that's correct. Because otherwise, and we don't want a mutable reference. We just want. I think that's what we want. And this one needs to be. Oh yeah, we didn't create a current. Let current equal input get index to.
You have to do that. Yeah, but you have to do that inside the if left, otherwise it's going to explode.
You're right. Yes. Sorry. Let current equal input dot get index and a wrap, because we know we can wrap. And now here we do current dot value. Cool. Right?
And so we sum it on the left.
Okay. I don't know what it's complaining about. I think we are missing some parentheses somewhere. There is an extra parenthesis. Why? Okay, now this is what I wanted to see. Can we do this? Cannot be dereferenced. Can we just do this?
Seems so. What is that get mut complaining about?
Can we use get mut in this case? What's the error? Cannot borrow input as mutable because it's also borrowed as immutable. Borrow occurs here, and immutable borrow occurs. Ooh. So when you use get mut, it's borrowing the entire input as mutable. And here we already borrow it as non-mutable.
Borrow that as mutable because in the end we have to set it to 0. So,
but I don't think we can borrow it as mutable twice. So this will complain in another way, saying that we cannot borrow it twice.
Yeah, but you are borrowing different elements or not?
Yeah, that's why I don't know how to solve this, because we want two different elements, right?
Yeah, in reality, we are touching 4 elements in the end when all of this will be written.
So one quick way to solve this, it's a bit shit, but for now we can do this.
Let's clone
if anyone
has
better suggestion, let us know, because this will release the reference on the input once we clone. So then we can get a mutable reference here.
Okay, probably this problem will pop up again because we have to mute all the elements.
Was suggesting to do this. Make a copy of current.value, drop current at 75. Oh, which is probably the same as doing a clone, right? I mean, clone is probably cloning everything, not just the value. so maybe a little bit more expensive. Yeah, I guess let's keep it like this, but also Tommaso's suggestion is probably good. Cool. So at this point, we have, what do we have? On the left,
We have summed on the left.
Sum on the left, okay. And at
Now
this
we have
point,
to
do on the right, right?
Yeah, we have to do not the current one, but the one at our right, that is, we are in a tuple of numbers. And when you do the line 73, you find the left one, but you also have a right one. This right one must be summed with the one at is right. So it must be summed to the one at index plus 2. So we have to check if index plus 2 is inside the sequence.
But the right one is index plus 1, right? Or
yeah.
not?
So we have to sum to index plus 2, index plus 1.
Okay.
So if
sum the value on the left with its
left
value on the left.
So it's
this
summing
one
index
sum
with index minus 1. This is must
right,
sum the value on the
if
right
any,
to the
its
no, there is
value
always
on-
any one, but at least to the one on its right, if any. The if any is only applicable to the first one. Because there is always valid inputs, remember the rule.
Okay, so value
if index plus 2 is less than
right, is equal on input to get
why
index.
if?
I don't know. I wanted to say let. And we can unwrap because we are sure this exists.
Yeah.
And we probably need to clone it because we have the other problem, the same problem as before. Okay, and now we need to do
almost correct, but minus 2.
Yeah.
But minus 2, not minus 1. Yeah. Then I don't know what is doing on the right. Is the mutable plus 2? Plus 2.
On the right, yeah.
And then you sum not current, but value on the right to on the right.
Let's call it num on the right.
Okay.
Otherwise,
renaming line 82. Okay.
Okay.
Here now we have to put in.
We need to add the 0 as well.
At the current index, we have to add a 0. So we have to overwrite what is at index with a 0. And then and then we have to delete an element. And here I want to see if we can, because I'm curious.
Ooh, look at that.
Position is the clone, but without the last element. Must be one level above. So it's
we
the
do
same as position, but not without the last element.
Is it a pop to remove the last
element?
Yeah,
we have to remove the last element. Pop is giving back the element, or is giving back what's left? No, pop is giving back the element. So you have to do.
Okay, let's do let mute new position equal this, and then new pos.pop.
Probably there's a better way of doing it. And now we have to remove index plus 1 because
wait, but we need to insert this 0 somewhere.
We have to overwrite the current number at index.
Ooh, okay.
Or we have to delete 2 of them and insert 1. I don't know what you want to do. What is easier to do, I mean.
Right.
Now at index we have 2 elements. We have to replace those 2 elements that are index and index plus 1 with this 0.
What if we do this? Is that gonna work?
Yeah, but what do we do with the one at index and index plus 1? We have to remove them.
Before or after doing this?
Before adding, after adding, I don't care, but we have to remove them.
Okay, so we need to remove the one on its. Wait.
We can pop index twice.
Yeah. Because we have something like this, right? L and R.
Yeah.
But they are represented as 2 separate ethnum.
Yeah.
Right?
They must become 1, 0.
So we are replacing both of them with a 0. So
but
one was overridden and the other one needs to be removed, right?
Or you can do before insert, you can do input pop of index. Can you pop from a specific position?
I think you can remove a specific index.
Okay. Input remove index.
Remove
2 times
index.
Twice. And then insert at index the 0. I think we have to write a test for this, and also we have to fix the cloning.
Why clone doesn't work? Is it unnecessary? What's the problem there?
I think it's necessary.
Why is complaining? Redundant clone.
Are we sure? what? Let's write a test and find out if it's really.
Oh, because I think we remove it later, so it doesn't matter. Does it?
I hope it keeps a reference and it's not destroying the object, but I trust Rust for this. Okay, but this is just an explode. Now we have to write the split.
Hello, Pascalone. Thanks for the follow. How are you doing today?
Are we returning true? Perfect. Cool.
We are returning true. Okay, so this is just the
explode.
Explode.
It also has to split. Probably.
So we'll need to check here the split, right?
Yeah, the split is another find, but this time the criteria is the value be greater than incredible.
Okay,
but, well,
so
it's wrong, but
it's a good starting point.
Sn.value
bigger or equal than
bigger than 9 or greater or equal than 10. Depends how you want to phrase it. 9, not 8, 0. 9. Yeah, this is the index to split. Now, to split, what do we have to do to split? If there is something to split, if let index equal some index, sorry, it's the other way around.
Stop Copilot.
Copilot is.
Okay, so in this case, when we split, what was the logic? We need to divide the number by 2.
Yeah, we have to divide the number by 2, rounding 1 down and 1 up.
So it's actually, let's do let current equal to yes, and then let left val equal to current.value divided
by 2. Integer division. Is Rust doing an integer division here?
Yes. And then let right.
Copilot is right.
Is current dot value minus left val. Yes, Copilot is right. Copilot okay, at this point we need to insert this.
This time we have to we have one number. This number must go away, and in its place it must compare 2 different numbers, one on the left and one on the right. So we can do again the input remove index to remove the index, and then 2 insert in the index and the index plus 1. 1 will be the one on the left.
Yeah, we need to create the position though, right?
The position is the current position plus an L, because this is the left one at the end of the current position.
Okay, let's do this. Left pose is equal to current.position.clone, and then let
dot push. Yeah.
Oh, this needs to be mutable, and then left pose dot position.
No, push. It's a vector already.
And we push a pos
L,
right?
Yeah.
And
we do the same for right.
Let's see if Copilot is smart enough. Yeah. Right. Pos. Yeah. The push. Beautiful. Thank you, Copilot. So this one gives us left pos.
The left pos. Then you have to insert in index plus 1. In index plus 1.
You're right.
Because it must go on the right. And the position is the left position.
The right position.
Yeah, the right position. Oh my God. Left on left and right on right, at least.
Okay, now here is complaining about another unnecessary clone. I'm not really sure I understand why.
The second one is not needed. The first is.
We have a question. Is better Rust or JavaScript with bun? I think that bun can only execute JavaScript, so I don't think there is an option to run Rust. So that's my answer. Okay, let's continue.
Probably it means it's faster Rust or JavaScript, but with the bun runtime.
I think, well, it depends on the application, but probably Rust is still faster because, I mean, bun is still interpreting JavaScript code.
Yeah, and by better, don't know.
So Tommaso is suggesting 110 and 111 can be swapped, and then we remove the plus 1. Probably,
yeah, it's true, because you add the right one, then you add the left one, and it will shift. I don't know if there is any performance gain, but yes, it's true.
Maybe it's doing one less shifting. I'm not sure. No, maybe it's the same. It's probably the same.
I would like to write a test for this because.
Okay, let's remove the clone. By the way, anyone knows why the clone is not needed? Let us know. I have no idea. And
let us know.
Okay, let's do the test for reduce, right?
Yeah.
Do you have any test that we can reuse?
Yes, give me a second that I have to dig them out of the grave.
Test reduce.
Take it easy. Google Drive is killing me with the slowness.
Here we have suggestions. Because the last usage is the last, Thomas is saying. I suppose for the clone.
Yeah, for the clone, because the last use is the last. That is making sense.
Okay, so it's like if we are cloning something that we didn't touch anymore, we just better off don't clone it and use the previous one. I suppose that's what it means. Okay, do you have the tests in your collab?
I sent you something. You got it?
Where did you send me?
WhatsApp.
Ooh, I don't have my WhatsApp here.
Okay, let's send it to True Collab.
Which I don't have here as well.
At this point, give me an option.
You need to send it by pigeon mail.
The
Okay,
pigeon. There is the pigeon here.
I think I found your collab. Share with me. Here. Okay, so this is what I'm doing for the records.
Go at the very end of this guy.
Very end, yeah.
No, it's not at the very end. I'm lying. It's the second square. Go up, 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 up.
This is part one,
There,
Robert.
there.
Okay.
Yeah,
Cool.
you have to change the format, obviously, because
Yeah,
yes,
we can manage. Okay, so what are we doing here? We are trying to do. Oh yeah, in our case. Yeah.
This was version 1 of my stuff. I was working with strings everywhere.
Okay, let's do let cases equal.
Let's start with 1.
What the hell, GitHub? Stop. I might disable it. Let's disable it. Come on. Disable for Rust. Okay, so what we want to do is this guy and this guy and true.
Yeah, you can have the parsed version of that guy on the right. Is easier. Well, we can do that. But true is there is still work to do. Is the boolean that come out?
Yeah, exactly. But we want to check that, right? We should.
Yeah, but I think they're all true, so it's not a lot of me checking all of them. But cool.
I'm gonna quote some.
Let's start with 3 of them. They don't do all of them. It's just too much.
Cool. System quotes in your input, Robert. Why?
Single quotes, but because Python doesn't care. Single quote, double quotes. Just be consistent.
Okay, so what we want to do, I need to close this thingy, is basically say...
Yeah, that reduce of parse of the first parameter must be equal to the parse of the second parameter and a true.
So we assert.
You don't do a for?
Oh, yes, for
input expected and expected the true. The coming.
Needs work.
Need more work. Yeah.
In cases.
Cases.
So what do we want to check is...
We have to set the assert equality between...
We need to parse the input first, right?
Oh, can't you do that in line in one expression?
We can, yes. So we want to do parse. Wait, we want
to assert equal. Assert equal. That reduce of parse of input. Probably you have to put some
input
ampersand somewhere. Is
equal the same as parse expected.
Of expected and the needs work boolean because it's returning a tuple. Reduce is returning a tuple, remember?
Right.
No, on the right. No.
On the right. So this one and true, right?
No. On the other side, you have to do this. On the right side, you have to do that.
Reduce. Oh wait, reduce just returns true. true or false.
Ah, it returns only a Boolean. Ah, okay, no, okay. Sorry, you're right.
So we need to assign it. We need to
you
assign
have to assign to a mutable. Sorry.
Let's mute
Parse the input. Yeah, expression.
Equal parse input. And that's it. Then we do reduce. Well,
we have to assert that reduce of input is needs work, and then we do another assert.
So let needs work equal reduce of expression. And now we can assert independently two different things.
Yeah.
So we assert needs work, expected needs work, and then assert equal of what expression, because it's been mutated, expected.
Yeah, parse of expected.
We need to parse, yeah.
We have to parse expected because it's a string.
Okay. Now it's already complaining about something. Consider mutable borrowing. Okay, yeah, mute. Actually, like the Rust forces you to do this because it's like telling you, by the way, reduce is going to change this guy. Make sure you
reduce is going to change expression. Okay.
Okay, should we run?
Oh, let's try.
Oh my God,
it's working.
I can't believe it.
My God, it's working. First try.
Legend. Let's break it. Let's do one here. Cool. Okay, this was set 0.
Put it back. I don't remember.
Let's add the other two cases.
If you want, you can add them. Yeah.
So we want to add a comma there and a double quote
true.
there, and lowercase true. And then the last one. And I think after this one, we can stop probably here for today.
Yeah, we can do the sum next time. Yeah, but this one is a lot of code. This exercise is a lot of code.
Okay, let's try to run all the tests. Do we want to add a case where it's false? Do we have one?
If you take the first line, line 198, you duplicate it.
Not remove it, duplicate it.
No, duplicate that line. Put on the left, on the right, the second parameter. The second parameter on the left and on the as first one. Copy the second one. First one. Copy, not to move.
Okay. Oh, you want that?
They must be the same. All of the two of them must be the same.
Okay.
And then false, because it means on this on this input there is nothing to do. So I give you back the same.
Which is fair, yeah.
I give you back the same, and I did nothing.
Cool, it's doing that. Perfect. So I'm gonna do a commit, and we are gonna do the closing. Working on part 1.
Yeah, now we should have done the sum that is using the parse and this is using the magnitude. So yeah.
Okay, so thank you everyone for being with us today. As we said at the beginning, we are trying to learn Rust. So basically what we do Advent of Code, and we put our things in the repository. Feel free to go in the repository and send us suggestions, PR, everything is accepted. If you
we have
we have a banner there.
Yeah, banner done.
And yeah, feel free to contribute and tell us what we can do better, because again, we are learning. So if anything helps, we will gladly take that. And we will keep streaming every Monday at around 6 p.m. Irish time, which should be 5 p.m. GMT. So yeah, that's pretty much it. So we'll see you next time. Thank you very much.